Let T1 and T2 represent the lifetimes of two linked components in a device. The joint density function for T1 and T2 is uniform over the region. T1 is less than T2 is less than L and everything positive. Determine the expected value of the sum of squares of T1 and T2. So first, let's see what the domain looks like. Um, it's the first quadrant, and we have T1 less than T2. So we draw T1 along the horizontal and T2 along the vertical. And this is the line T1 equals T2, like the line Y equals X. And this region will have T1 less than T2. You can see T2 values are higher in this blue region. And since we are told that the joint density is uniform over this region, whenever the joint density is uniform or constant over a region, then it's just equal to the reciprocal of the area of the region. So we need the area of this triangle, which is just half times base times height, and both the base and the height are L and L. Because if we have to stop at L, since T1 and T2 are both less than equal to L. So domain area is half LL, which is L squared by 2. And so as we said, the joint PDF of a uniform or constant distribution is the reciprocal of the area. So it's 2 over L squared in the region that is given. And so we need expected value of sum of squares of T1 and T2. That means E of T1 squared plus T2 squared. And the basic definition of that is the double integral of T1 squared plus T2 squared against the joint PDF. And our integration region is just that blue triangle that we saw above. So in this case, the integration is slightly easier if you go through a horizontal strip like this, which means that first you are integrating from T2 equals, from T1 equals 0 to T1 equals T2. So first you're integrating with respect to T1 from T1 is 0 here, because this is the T2 axis. On the T2 axis, T1 is 0. So T1 is 0 here and T1 is T2 here. So the inner integral is for T1, and that goes from 0 to T2. And then the outer integral is for T2, and so that would be from 0 to L. So that's what we have here. And then we substitute the value of the f of T1, T2. And we integrate the inner T1 variable first. So this one is T1 cubed by 3, and this one T2 squared is just a constant. So T2 squared times T1. And T1 goes from 0 to T2. And then when you substitute T1 equals T2, this becomes T2 cubed by 3, and this becomes T2 cubed, and the lower is 0. And so these two add up to 4/3 T2 cubed. And now you integrate with respect to T2. So 2 over L squared is a constant. And it's 4 over 12, the integral of this. And it eventually reduces to 2L squared by 3, which is choice C.